This is a re-upload for archival purposes of my older content. This video was originally uploaded to Experimental Madness in 2017. See the full story in description.
Microgravity. Now you have probably heard of zero gravity before, but zero gravity is impossible. It doesn't exist. As long as there is two particles in the universe, there is gravity. This means that the floating astronauts in the International Space Station are feeling very small, unnoticeable gravity. Because they are constantly in free fall, falling towards the Earth, but they never reach Earth, because they are thrusted tangential to the Earth and loop around it before they can reach it. This is called microgravity, as it is very small gravity. Imagine I was on an asteroid in space with rather low gravity, and I threw a ball weakly tangential to the asteroid. The ball will fall down in a parabolic trajectory, but if I threw it harder, it could go around the asteroid without ever falling. It would experience microgravity. If I throw it even harder, it would escape the gravitational pull of the asteroid. If I were to throw it off Mount Everest, I would have to throw the ball at 7.89 kilometers per second. That is almost 7 times faster than the fastest bullet. Plus the atmosphere would slow down the ball anyway. So how do we simulate microgravity on Earth without having to send rockets up and spending millions of dollars? Well, the drop tower, of course. So what is a drop tower? Not the theme park ride. A drop tower is a tower that drops a package usually containing a scientific experiment in freefall, and the package experiences microgravity just like our ball. You can experience microgravity yourself every time you jump. Jumping into microgravity is not long enough to conduct a scientific experiment. NASA has a microgravity drop tower at the Glenn Research Lab, and it has a total time of 2.2 seconds of free fall compared to the short time when you jump. The problem with this idea is that it is not true microgravity, as the package is falling at 80.5 kilometers per hour, creating lots of air drag, slowing the package down. To achieve microgravity, the package is put inside a box and is held against the roof of the hollow box, so that when the air slows down the outside box, the inside package isn't affected by the air. Other drop towers around the world, like the Bremen drop tower, removes atmospheric drag by pumping out the air in the drop tower to 1/10,000th atmospheres and takes 1.5 hours to remove all of the air. There isn't many other ways to simulate microgravity on Earth. I made my own microgravity drop tower. I filled the box with lead to weigh the box down and minimize the atmospheric drag. The candle flame shrinks because in microgravity there isn't any buoyancy to create convection that lifts the flame up, and so the candle burns more slowly as it doesn't have oxygen constantly feeding through it. This is microgravity.